So my name is Steve Hodges. I'm one of the research staff at Microsoft. Usually, when I give a talk about technology, when I give a talk from Microsoft, I'm talking about some kind of technology, some research that I'm doing, and I spend 20 minutes, half an hour talking about that. But today I thought I'd do something a little bit different, actually. I thought I'd tell you a little bit about me, what I do in my job at Microsoft, which essentially is researching and engineering, inventing future technologies. And I thought I'd try and give you a little bit of a flavor of what it's like to work for a big tech company like Microsoft. Along the way, I hope to demonstrate why computer science is so important, not just working for tech companies like Microsoft, but much more generally, and why I think you guys are all in such a good position, given your interests. But I thought what I might do to start is kind of put myself back in your shoes a little bit. So I'm 46 years old. So rather frighteningly, it was about 30 years ago, 35 years ago, I was your age. Okay? So that was the early 1980s. And believe me, computers looked really different 35 years ago. So a little bit more than that, a little bit further back in time, in the 1970s, computers really were incredibly special. So you had to be pretty privileged to have access to one. They were often in special rooms, like maybe it was air-conditioned. But thankfully, in the early 1980s, computers did become more prevalent. And in particular, there was this class of computer we called the home computer. So households up and down the country had devices like this. I had the BBC Micro in the bottom left, along with like a million other households in the UK, and there were a variety of different machines. And so up and down the country, kids like me were not just playing computer games, but we were getting really fascinated by these. I was fascinated by this device, like how I could program it, make it do different things, how it worked, how it was put together. And that really sparked my interest in computing and in technology. But luckily for me, and I think for many other kids growing up back then, these computers weren't just limited to homes. They were in our schools as well. And my school had a bunch of BBC microcomputers, and they offered, because of, through this, really, it enabled the school to let me study computer studies. So I've got an O-level, the equivalent of a GCSE, in computer studies. And this was, up and down the country, there were schools doing this. And the BBC actually had a big part in this. Not only did they lend their name to that particular computer, but they sort of orchestrated a whole ecosystem. So you could buy the computer, but you could get peripherals that work with it. You could get disk drives and printers and so on. But more than that, there were learning resources. There were teaching materials. There was so much sort of support information. And, of course, they made several series of TV programs that explained what computers were, why they were going to be important, how they worked, how you could program them. So I studied computer studies. I got my O-level. I went on to do my A-levels. I did maths, physics, chemistry, and my school gave me the chance to do electronics. So I studied electronics at A-level. And then when I went to university, it was fairly natural to me that I would apply and study. I studied computer science with electronic engineering. So I did this kind of joint honors course. And although the subjects I got at O and A-level, the computer studies and the electronics, weren't prerequisites for my course, those were the things that helped me realize that was what I wanted to study. That's what I wanted to do. Now, this very curious thing happened when I was at university. My school kind of stopped teaching computer studies. And it wasn't just my school. Schools up and down the country, this is really bizarre. Computers, the early 90s now, computers were becoming more and more prevalent. It was clear that they were going to impact all of our lives. So schools had to be teaching everyone about computers. And they did that, but in that rush, they stopped teaching computer studies. They stopped teaching computer science. Like, they didn't tell kids how computers worked, how to program them, how to build them. They focused very much on getting students to understand how to use computers as a tool. Now, that's vitally important, of course, but along the way, something was lost. And that situation continued for many, many years. But thankfully, a couple of years ago, the government realized that this was a big deal, that we weren't heading in the right direction, really, and they put computer science back into the national curriculum. So now, all children, all students from primary school upwards have to learn something about computer science. And so this got the BBC to thinking, actually. You know, back in the 80s, they'd really sparked a lot of interest in students around computer science, and they wanted to know if they could do something. They were thinking, well, can we do something as a corporation to spark that interest again? Now, the government said everyone's got to learn about computer science, but can we get students really interested? And they came up with this idea called the BBC microbit. So has anyone here heard of the microbit? Can you put your hands up if you've heard of it? A few of you have. Okay. So that's good. What the BBC decided to do, you know, the world's moved on a lot since the 80s, of course, and back in the 80s, the BBC Micro was this self-contained general-purpose computer. But those are a lot more accessible today. Like, a lot of households already have some kind of laptop or desktop. They have this general-purpose self-contained computer. So the microbit is a very different thing. It's a much smaller, cheaper device. I've got one here. And it is kind of self-contained. I can plug a battery into it and it'll operate. It's got some LEDs on the front so it can display messages. It's got some sensors. It's got Bluetooth. But it's a little bit different because it's, in order to program it, you do need one of these self-contained computers. You need to plug it into a laptop or a tablet over USB, write your code, and then download it to the device. But it has a very similar aim. It's designed to really try and get children, students interested, right? To pique the interest, to think about what could I do? So I've got this programmable device to spark an interest in computing and programming. The really exciting thing about the microbit in my mind is that the BBC, together with a consortium of partners, which Microsoft is one of them, have arranged so that we can, in early next year, we'll be giving away 1 million of these microbits. So students in year 7, in fact, every student in the country in year 7 will get one of these devices for free early next year, which is fantastic. And part of my job at Microsoft Research over the last year has been designing this thing, right? Specifying what it should do, how it works, working out how we can make it cheap and reliable and robust and do the things that we want. And in particular, it's important to understand it's not just for year 7. There are actually a number of different programming environments and ways of using it which we've designed so that it will be accessible to some students younger than year 7, but there's plenty of headroom too. So students who are much older and more advanced can also get a lot out of it. In fact, you can even program this thing in C++ or in ARM assembler if you want to kind of pick up those skills. And those are the same, you can use the same tools that professional developers would use when they're developing for embedded systems. So, hang on a minute. The government said that everyone needs to learn computer science. The BBC has got together with a bunch of people to really get students excited to learn about computer science. Is coding really that important? Well, let me give you a statistic, okay? So, over the next 10 years, there are going to be 1.4 million new jobs in computer science. And that's in the US alone. So current predictions are that over the next 10 years, if you look at graduates from university, people graduating with the right kind of skills to take up these jobs, there's going to be 400,000 of them. So that's a shortfall of 1 million. So hopefully you begin to see the importance of computing and the value of computer science. But in case I haven't convinced you, what I thought I'd do is hand over to one of my colleagues at Microsoft and some of his friends.
We all depend on technology to communicate, to bank, and none of us know how to read and write code.
The first program I wrote asked things like, what's your favorite color? Or how old are you?
I wrote a program to play tic-tac-toe.
I first learned how to make a green circle and a red square appear on the screen.
You're just trying to make something, trying to transfer something from your mind to the computer or to a tablet. It's an experience.
The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
The programmers of tomorrow are the wizards of the future. You know, you're going to look like you have magic powers compared to everybody else.
Great coders are today's rock stars. That's it.
So it's interesting to pick up, I think, on that quote Mark Zuckerberg said in the video there. He said, the whole limit in the system is that there aren't enough people with these skills. Some companies are going to amazing lengths right now to hire the best, the smartest people. So hopefully that's made you all feel good about the kind of the skills and the interests that you guys have. But let me show you this other snippet of video.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry.
Snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office and places where people can play or relax or go to think or play music or be creative.
So like I say, hopefully that's kind of making you feel good about this kind of skills and interests you guys have. But you still might be thinking, does every student need to learn how to program? Not everyone's going to be a programmer, right? So why is there this emphasis? So it's really important to understand that computer science is so much more than just programming. You know, there are things you learn in computer science, like a specific computing language or a particular API maybe, but that stuff dates really quickly. What's important when you learn computer science are the foundations that you learn, the principles, the ideas, the methods, the techniques. It's a way of thinking about problems, a way of understanding the world. And ultimately, that foundation in computer science helps us all understand technology as well as just using technology, and it helps us create the next generations of technology rather than just consuming the current generation. So just like we teach everyone physics, right? And it's not because everyone's going to become a physicist, it's because that foundation that gives you the understanding, the way of learning about the world is so important. And the same is true for computer science. And that's where I come back to my job. So I have this degree in computer science with electronic engineering, but I don't write code. And yet I wouldn't have got the job that I've got if it wasn't for those qualifications. And I wouldn't be able to do my job if it wasn't for that background, that foundation that I have. Every day I'm thinking about new technologies, and I'm developing aspects of them. I'm developing electronics, I'm thinking about industrial design, I'm thinking about interaction and user interfaces, and I need that foundation in order to do that kind of work. I need that foundation to talk with all my colleagues, to share ideas and develop things together. So I thought, by way of illustration, I would actually talk about a project which Microsoft announced not too long ago. The project's called HoloLens. Has anyone heard of HoloLens? Okay, fantastic. So I'm really excited by this project. It's, on the face of it, this is a HoloLens device. So it's a wearable. It's a headset. You put it on. It's perhaps a bit like an Oculus Rift, but unlike Oculus Rift, which is a virtual reality system, it sort of hides your view, and you just get to see a computer-generated content. This, the visor here is partially transparent, so you can see the world around you still, but the digital graphics are being overlaid on it. Now, this is called an augmented reality system. To give you a little bit better idea of what it is, I think the best way of explaining is for me to show you a video.
What if we could go beyond the screen, where your digital world is blended with your real world? Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. the world you see.
So I think HoloLens is a fantastic example, right? It brings together so many skills and across so many different disciplines. So literally over 1,000 people who work at Microsoft around the world, including some of my colleagues up the road in Cambridge, work together to create HoloLens. And it needs skills in hardware, it needs electronics, it needs optics, industrial design, mechanical engineering, manufacturing. Of course, there's programming skills required. We need to think about signal processing, how we process all the data that this thing is loaded with sensors, how you generate the graphics. It's got machine intelligence built into it. And then, of course, there's the whole interaction, the user interfaces, and how it's used. And all those people, those 1,000-plus people at work at Microsoft, the thing that helps them all work together and rally behind a project like this is the foundation that nearly all of them have in computer science. So for these people, working on HoloLens isn't just their job at Microsoft. It's actually a once-in-a-lifetime opportunity, if you think about it, to work on something that's really magical, something that has the potential to change the way that we all interact with the computers. And so they're really excited about bringing this thing, making it real, and seeing how it can transform how people use and interact with computers.
They've been working on this for, years, secretly. You need to have a bunch of obsessive people who see this as a meaningful part of their lives.
This is by far, far, far the hardest, most complex, most challenging, and most intriguing thing I've ever done in my life.
I mean, we are literally smacking up against some of the laws of physics on what we can and can't do with light.
For all this complexity, it has to be incredibly easy, incredibly familiar, incredibly universal how you use this new palette.
We just recently started engaging with third parties to build applications for the device, and the things they're doing just, they're humbling.
When you've got 1,000 different people from all different backgrounds with all different types of experience, you're going to see that the stuff that we've built at the beginning is just a tiny scratching of the surface of, what this technology can do and what it can mean for people.
When the other perspectives come to it and all the creatives out there, it's going to blow our minds.
This is a new medium for artistic expression and a new medium for creation that we've just never had before.
This platform is going to truly blend your digital life with your physical life. And it is so thrilling. This is truly about seeing the world in a whole different way.
So I think that's a good place to finish, really. To summarize, I spent the last 25 minutes or so telling you a little bit about me, my job at Microsoft, my role researching, inventing, engineering the future, along with many other colleagues. I told you a little bit about my background and how I ended up with this fantastic job. And along the way, hopefully I've illustrated why computer science is so important, not just if you want a job as a programmer, but any kind of job in technology. And in fact, any kind of job full stop. If you've got that solid foundation in computer science, that's going to put you in a really good position to get all manner of different types of job. So I want to end by something I mentioned, picking up on something I mentioned in the introduction here. So you guys are all at a really interesting point in your lives. You're making choices, right? You're choosing what subjects you're going to study at A-level. You're thinking about where you're going to go to university, what degree course you might study, and ultimately you're going to be applying for jobs. And together, all those decisions are going to affect your career, right? What your career path is, what vocation you end up following. So really the message here is think. Think about these decisions you're making. Think about where you want to take things. And as you do that, also think about how you best go about engineering your future. Thank you.